Okay, so one of the things we have to think about is when we design a sensory test, we're asking a question. We have some sort of thing that we want to know and understand how our product is performing. Is it different? Are consumers going to like this concept, etc.? So when we ask a question, we first need to do some background research. What was done? What did the results show? And how is what you're going to do different from what was already done? Yes, companies have money, but companies are not going to waste money on rerunning a test if they already have some information. If the test is several years old, they may reconsider it because we know the consumer is dynamic and always changing, but they're not going to rerun it. And companies are very cautious with consumer testing because it is pricey. So when we look at our objective, so once we find out what our background is, it should end with an objective. You can have two types of objectives. One is either for the entire project and or a single test. So a project objective would be to substitute the black blend cocoa from manufacturer A to the black blend cocoa from manufacturer B in an Oreo cookie. So you can think about that from a sensory perspective, but you also have to think about that from a color perspective, from a sensory and quality perspective. You have to think about that from a processing perspective, because how is that cocoa coming into the manufacturing facility? Is it going to be an easy 1-1 switch? Is it going to clump? Is it going to change times in how it's processed, etc.? So you can think of it for you can have objectives for an entire project and for a single test. And when we create a test objective, we should know who, what, where, when, how, why, and the product prep that's needed. Who are the subjects? What specifically are they going to test? Where are they going to test? The what specific is what variables, how many samples, is it too much, is it not enough? Where are they going to test? Are they going to test on-site, off-site, in a controlled environment or a lack of controlled environment? What time of day? How are they going to be tested? So what tool are you going to use? What type of scale? Think Noir. Is there going to be consumer information? Why are you doing it with this test? And what do you need to do to prepare the product? Because if you are doing an ice cream test, you need to serve that ice cream at the typical serving temperature of ice cream. So if you're serving ice cream to consumers, how are you going to manage sample prep? Think about it. That's a frozen product. What happens when you pull that frozen product out of a freezer? It melts. How long of a time can you have before that consumer tastes it? So these are things you need to consider. Then we have to analyze the data and draw a conclusion, and we need to consider what statistics we're going to use and why, and how we're going to interpret it. When we design a test, and here is where Brian Wansink failed. He did a test, he didn't get the results he liked, so he parsed his data until he found some information that he could report. That's not good science. And so, yes, we know we can do statistics with a hypothesis, and yes, we know we can do other types of statistical analyses where there's no hypothesis when we look for clusters and patterning of consumers. But we need to decide that in advance. When you design the test, you need to think of the statistical analysis you're going to do ahead of time. For our food science students, when you do your senior project, when you design it, how are you going to analyze those results? Should be one of the first questions you ask from a statistical standpoint, and have that as part of the statistical design. For my business students, I don't know how your senior project works, but I'm sure there's some sort of similar thing to consider. And then you report the results. How does it match or not match the objective? Did you validate or invalidate your objective? So when we think about the considerations of the statistical tools, we need to take a look at our hypotheses. Are we comparing one sample to a population value? That would be a population t-test. Are we comparing two samples? And if we're comparing two samples, that's our t-test. If we're comparing 3 or more samples, that's an analysis of variance. If we're looking for identification of patterns in data, those are typically hypothesis-free types of tests. We need to know that in advance. So if you think of comparing an Oreo cookie from production of all your global production values from across the world to this gold standard, that would be where you would use a population t-test. If you're comparing Oreos with the new cocoa, that could be a t-test. If you're comparing 3 or more samples of different types of sandwich cookies, that would be an ANOVA. If you are looking for patterns, consumption patterns of individuals and how they eat cookies and what the cookie spectrum looks like, then you would have a different hypothesis or objective, I should say objective, for this type of test. So just to recap, affective testing looks at the hedonics, what people like, their preferences or acceptance to the product idea, or specific product characteristics. Discrimination testing is testing that can be used to determine if a difference exists in a product. In these tests answer only one question: is there a difference or not? And this goes back to the Thurstonian modeling that we just talked about. And then we have the descriptive testing, which is the analytical sensory testing, where you train your subjects to be instruments, not consumers, not product users, but instruments to analyze fine differences. A descriptive panel should be able to detect small differences in batch-to-batch samples of cookies produced in a production facility. That is where you're going to do descriptive testing. This is the group that's going to drill down and really help you identify those fine differences. Oops. Okay, I'm going to pull this down here. When we take a look at the test methods, and we're going to recap some things, discrimination test needs 30 subjects. Those 30 subjects need to be product users. The tests that they're going to do are paired comparison, duo, trio, triangle, A, not A, tetrad. Those are the types of tests they'll use. In a descriptive panel, you're going to use 10 to 15 consumers. Not consumers, subjects. I take that back. Discrimination testing, validated product users. Descriptive testing, you're going to use trained subjects. And those subjects are going to use a couple different descriptive analysis tools. We'll talk about a couple of those, the QDA and the spectrum method, after the second midterm. We'll get into a lot more details on descriptive. For affective testing, this is where we're looking at acceptance and preference. This is where we want 100 consumers. So to walk through this one more time, discrimination tests use product users, and they have a certain use pattern or category. Descriptive, humans are trained to be analytical instruments. Descriptive panelists are trained. Discrimination, the ability to discriminate a difference if it's present, does not use a trained panel. They use product users. Affective testing, where we do hedonic, is 100 consumers. Now, when we replicate, and when we do a pH measurement or other sort of physical property measurements, we always replicate. And one of the things that you should be thinking about here is what makes sense in terms of replication. In the case of a discrimination test, you might want to replicate it twice. So you might do the test in duplicate. The same subjects get the same samples served in a different order twice to see if they were able to guess by chance or not by chance. And they can do that within a single session sitting in a booth. For a descriptive panel, you will replicate, and you'll probably replicate 3 to 4 times per test, and you very likely won't replicate on the same day. That replication would occur on more than one day. With affective testing, you are not replicating, and there's been statistics and studies done that have used statistics to indicate that replicating with consumers is generally not a good idea. One of the things, or some of the things to consider with replication, you need to determine consistent sensitivity. You wouldn't do just one pH measurement. If you're looking for a difference or you're quantifying that difference, you're going to want to replicate. When you replicate, you do create a more precise sensory instrument. When you replicate, you can then understand, and this is going back to the psychophysics, you can then understand how each individual varies with each measurement that they take, and you can track that information. And you can think of it as kind of insurance to understanding what your panelists are doing. So when you're not doing a consumer test and you're doing discrimination and descriptive, you are going to want to track to see that your panelists can detect differences. Here is the trade-off. At some point, if you replicate, too much replication may lead to false differences being detected, and they have no value. So you can replicate, but how much replication is enough replication? Usually 2 to 3, usually in the case of descriptive, you're 3 to 4 times. In the case of discrimination, you're 2 to possibly 3. Also, there is another trade-off to replication. It's the cost. Think about the time to set up the test, to prep the products for the test, the cost of shipping it to a test facility, the supplies, the cost of production, packaging, testing, and the cost of testing. When you think about what it is like to set up the sensory test, when you come into class and half the class will help prep the products, put them in cups, and get the trays ready, that takes a certain amount of time. But think about what's been done prior to your coming into class. All of the products for you have had to be blinded, or the products have had to be made. So when you think about that, when you have 100 people, or if you're training a panel to have references and things, it's an awful lot of time and money to do so. When you talk to a statistician, here are some considerations. Is it parametric or non-parametric? We've talked about this before. It's based on this scale. Univariate or multivariate statistics. If you're asking just a question on texture, that's a univariate statistics because you're examining one variable. When you do all attributes, so appearance, aroma, overall liking, flavor, texture, aftertaste, those are multiple variables, and you need multivariate statistics. When you do an ANOVA, ANOVA, that's analysis of variance, you're assuming it's univariate because you're measuring and doing an ANOVA on that variable. What should be done in sensory is the first test you should do is multivariate statistics. If you find that the p-value is significant, then you do univariate statistics across all attributes, and then you do your means comparison. Because there's always attribute differences, typically sensory scientists skip the multivariate in these particular cases because they know that they're going to find a difference in certain attributes and not in others. Independent judgments versus dependence of judgments. This is an expectation. In human subjects, independent judgments aren't realistic. Humans are going to have, when we have to keep an individual human subject's data together, it's because they are dependent. They are dependent on the judges. The fix to this is balancing the design and randomizing the presentation and the sensory prep. That will help. That'll help accommodate that in a statistical analysis. Also, random selection of subjects versus fixed selection of subjects. Remember, you only want to know information from certain types of consumers. By nature, we are using a fixed subject selection. It is not random. Sensory testing rarely uses random subject selection. Okay? So to recap, we talked about the different psychophysical laws. We talked about Weber-Fechner, we talked about Stevens, and we talked about the role of Thurstone. We also we talked about key statistical considerations that influence how sensory tests are designed and data collected. And I think it's very important when you talk to a statistician, and your takeaway from this class is understanding what a statistician does and what you as a sensory scientist need, or a human subject scientist need, to understand these data.